I'll try to zoom in where I can and whatnot to make it a little bit easier to see. Cool. So thanks for coming. This presentation or this meetup is more of a geared towards like a conversation way of doing this, as opposed to I say my ideas and then you listen and then there's no interaction. I'd rather that there's questions and we can debug or actually come through some conclusions as we go along. The title that I had to give for the meetup was Visual Studio and Docker. I will be doing Visual Studio and some Docker. But I wanted to propose a scenario, and the more I do my normal work, this seems to be coming up often, where you have legacy systems and you have greenfield, which is the new projects, and the new projects always seem to go for .NET Core because it's the new hotness, and then you always get this question, well, what about my old systems? What about my old WCF or my old API or my database, and what happens to those in this world that you move forward? And how does Docker fit into this whole equation? So I just wanted to tackle a certain aspect of this. In my presentation, I'll be a WCF service. I'm going to treat it as if a legacy system. So I'm going to have some code, I'm going to build it, I'm going to put it into a container, and then I'm going to run it, and I'm going to test that I can talk to it, and I'm going to have another system that will actually interact with this WCF in a very simple manner, but effectively talk to each other, and I'm going to reference a database. Those are the components I'll be talking about, and then we'll actually break it apart and say, okay, this is how things can work inside a real system. First of all, just a shout out to some of our sponsors. They help us keep the lights on. JetBrains is one of them. There was actually a competition out for this meetup. Didn't get many pull requests, so I'll extend it to the next month as well. They've given us a license that we allow to give for free. It is an open license, so if you like Rider, which is their .NET IDE, cross-platform, actually use this IDE, then you can use that license there, or if you like ReSharper, because you want to make Visual Studio more awesome, you can use it for that. It's really up to you. It's an open license. Obsidian, they sponsor the food and beverages. Unfortunately, there's no beverages today, but they give us the ability to do that. And GitKraken is also a recent sponsor. They are sending us some swag. Unfortunately, because of our wonderful country, customs and stuff, because it comes from the States, it's stuck in customs at the moment. But for the next meetup, we'll have some swag, and also Rancher has come on board with us as well. So they'll be doing a presentation next month with us, doing orchestration of containers, and they'll be seeing us some swag as well. And that swag will be handed out similarly to the way we did our Docker t-shirts. Right. The problem statement that I have here.
Sorry, Leroy.
Yo, yes.
Do you know what tools they're going to be using for orchestration?
As a
Or they're going to be just demoing and stuff like that?
So Rancher will be demonstrating their platform.
Okay.
In terms of the Rivco, it's not official at all.
Okay.
The idea is to present Kubernetes. Sorry, just let you guys know who this magic person is. we have some people from Isle of Man, and let me just minimize this.
It's like underneath this.
Perhaps I should introduce myself.
There you go.
Yeah, there we go. And we have Chris, Andrew, and Lance. Lance is from Isle of Man. Chris, are you also from Isle of Man? Andrew?
Yeah, they both are.
Okay, cool. So we have Isle of Man as well that's joining us.
Yeah.
Lance is he's in our team. He's also a configuration engineer with our team. Also helped with some of our deployments and so forth. Sorry, Lance, what was your question? You got anything else?
No, I think that's all for now. I was just curious to, what they're going to, or what's being looked at for container orchestration. I mean, obviously we've looked at Kubernetes.
Yes.
But yeah, I just wanted to see if there was something else that was going to be pitched or whatever.
So the demonstration from Rancher will be using Kubernetes. as the orchestrating
Okay.
platform. Cool. Ayo.
Okay.
Cool.
So what? Okay.
Yeah?
So bear with me. What is Rancher?
Ron?
Just a quick.
Yeah. So an overall, so in the container orchestration space, you get different orchestrators. Docker Enterprise Edition, known as EE or UCP, is one of them.
Yeah.
They use natively it's Docker Swarm, but it's moved over to Kubernetes. Then you get OpenShift, which uses Kubernetes as well, but they have their own flavor of the validation above it, and that's where their application shines.
So Rancher is like OpenShift.
Yes.
Okay. Cool. Gotcha. Right.
Cool.
Cool. Thanks.
Cool. So one of the problem statements that we usually run into is I have this virtual machine and I put my application onto this virtual machine and then I share it to my buddy that sits next to me and he puts his changes onto this virtual machine, and slowly as life goes on, that virtual machine that's shared now becomes dirty in a way in terms of there's too many changes, so now I can't trust the data or I can't trust the state that this virtual machine is in, so now I create another virtual machine because the first one is now, it's gone past the point where I can undo all these changes, so I'm just going to duplicate it and start afresh again. Now I've got two virtual machines. And then I make some changes, but now I have this weird permutation of the state of my application needs to behave, so I create another virtual machine. And as this starts propagating, I end up with 4,000 machines on my infrastructure. And it's like, what is going on here? So that becomes unwieldy to maintain. And at the end of the day, all you're doing is, apart from production, I'm talking about in the beginning of your development lifecycle, all you want to do is test, or you want to test your application in a certain scenario against something else to make sure that it's working fine. And when you're done with it, you don't care if it's there or not. And this is where the cloud kind of shines, where it says, oh, bring up your machine, do your test, and shut it down again, which is very nice, but in the same token, it's also very expensive in certain scenarios to be able to do that. So that brings to the second point, which is wasted resources. So you either leave it there, and the company at the end of the day pays for that fight, because now they have all these virtual machines, or it takes the company wastes money on spending salaries for people to look after these machines, or you're wasting credits inside the cloud. So that's wasted resource. And because, as I said in the beginning, it's a shared resource, so it becomes unstable. So you can't really trust that it's, especially if you're doing integrations, you can't really trust that it's in the right state. So the solution, run dependencies locally. So this is the concept of, and there's a couple of tools out there. Chef does a pretty good job at this. Vagrant also does a pretty good job at this. But we're going to say, I can't afford for an entire VM or VM cluster to run on my virtual machine or my desktop because it's not powerful enough. I need something a little bit more lightweight. And set up environments before running the solution. I want to stand up supporting infrastructure, debug my solution, and then rip it down when I'm done with it. And that's where containers shine, especially Windows containers, because we're in a .NET world. Build a container itself. So this is the problem statement that I mentioned in the beginning. I'm going to take a solution, a WCF application. I'm just going to build it, and then I'm going to run these two commands. I'm going to run it against, build my Docker file, and then I'm going to actually run that Docker file. So there's two commands, and I'll show you what it means. So here's my solution. Oh, crap. Sorry. Put my mouse over here. There we go. So over there, I have my WCF console application. All I've done here is I've created a Visual Studio solution, and I've added this WCF application over there. It's a very silly, simple application. Minimize that. Wow. There we go. It says hello. Super high IP there. It says hello, that's all it's going to do, right? But effectively, all I'm wanting to do is present that I have a WCF service. It's conceptually, before Web API days, you would have something like this. You would interact with it, it would talk to a database and would return you some data. And it uses SOAP services. Okay, so I'm going to just build it in Visual Studio. Oops. Build. Should put fine. Explorer. There it is. Yeah. Yeah. So I'm just trying to see this. August, there it is. So all that's happened is created my exe. Okay? No, not rocket science. What we will note is configuration of set. Is the IP address. Okay? So I've given it a static IP address because I want it to behave in a specific way. This IP address, I'm going to address it just now using WCF test client and actually invoke the method, the test method. Okay. So I have this exe. Now in this scenario, you can say, I have a legacy application that I got it from this exe from a server, an existing web server. It's running this WCF service. Imagine it's talking behind the scenes to a database, and I want to put this into a container and run it. So notice that in this solution here, I have a Docker file. I'm going to show you the Docker file. So my Docker file is very simple. Oh, come on.
Also, it's lagging a bit, I think.
Yeah, it's lagging, sorry. I'm saying use this Docker image, which is Microsoft.NET Framework 4.6.2. Very simple. Expose port 80 and port 808. 808 will be the TCL connection. I'm going to create a folder called app. For the guys that don't know what this command is, whenever you specify a working directory in your Docker file, it's going to create a folder if it doesn't exist. So at this point in the base image, there was no app folder. By saying working directory, it's going to create a folder and then go into that folder at that point in time. So your context now, which you'll see in the next line is dot, says put it into whatever I'm talking about, put it into this location. So the next line is copy bin /debug, so that's the folder that I showed you just now with the exe and the config and the metadata file. Copy it into my current location, which is app. Then run the command, because I'm in the same folder, I'm going to say cmd, which is available in .NET Core, in .NET Framework, the base image, run the exe. So that's the last execution point, and then it's going to stop. So if you exec into this container at this point in time when it's running, you'll automatically see in command line the output of whatever that exe is doing. Okay. So if I do my command, I'm going to build this. Okay, copy. It's not working.
So it's the dotted bit in.
Hey?
Dotted bit in. I'll add to the dotted, sorry.
Oh, wait, it might be the wrong place. So it's built now. So just to go over this command, Docker build, it's a Docker command. -T means tag this image that I'm going to create. WCF service is the name, colon, and your tag number. So whenever you're saying -T or -tag, you have to specify your image name, colon, the tag name. And the tag name is just like a reference point for what this configuration is going to be. If you don't specify colon with a tag number, it assumes latest, and then it will just append latest to it as well when you push it into the repository. The dot at the end is your current context. It's saying, in this location, there is a file called Docker file, and I'm going to use that to create this. What you can do is if you don't say dot, you can say // and you can give it the Docker file name. So in a scenario where you want to create it for a specific environment, say your staging environment for some reason, and you don't want to inject certain environment variables when it's running, but you want to build it in a specific way for that environment, you can have stage.dockerfile, and then here you say -f, and you give it the Docker file name. And that way it'll actually use that configuration file. That's useful when you're using a build service like TeamCity, VSTS, Jenkins, that kind of stuff. Cool, so now we have our image. To prove it, I'm going to go Docker images, and I will have an image. WCF service, and the tag is self-hosted, and there's the image ID. Okay, this is a brand new image. Now I'm going to run that image. Copy. So again, Docker run is a Docker command. -IT means interactive. What I can do is, instead of running it interactive will connect your current terminal session to the running container. So this is useful if you want to do debugging, or you want to see outputs of what's running inside your container. So now you're doing I've seen a lot of people do this with Python, is they run a command against the Python Docker image, they port their code across into it, and then they run certain commands that can pipe out the outputs and expose it inside a build system or some sort of logging or something like that. It's rather useful. But we're going to say -D. And -D means detach. So execute and let this terminal release itself. -rm means when this container stops, remove it immediately. So there's two major states of a container. One is when it's running, the other one when it's stopped. When it's running, it's obviously running, so everything's 100%, but you can also say Docker kill and the container name, and all that does is stops the execution of that container, which means any execution in a container, like an exe in this case, will stop. Then you can start it up again, and as if it never stopped. So that's useful if you have a service in this case, and you want to stop it because it's abusing your network, and you want to see what's going on, and then you can start it up again. Which is quite useful. Detach is allowing us to fire and forget effectively. RM, remove, -- name, I'm just giving it an easy name. If you don't specify it, because it's not a required field, the CLI will give it an awesome name at the end, and that's random, so you don't know what it's called at that point, so you have to like query it to find out what's going on. And then the image is at the end, image and tag, so WCF service, self-hosted. So that awesome number that's over there, that's the container reference number. It's like a hash kind of number of the container, and that matches a folder on the file system where the configuration for the container lives. Now we're using Docker for Windows, so we are using Hyper-V in the back end as our virtualization layer, and that configuration and all its pointers are in that folder that has that same name. So that's why that's there. Let's wait for it to fire up. There we go. the area they gave me is that I already have a container with that same name.
It's probably a kill
Yep.
name.
So Docker Kiln, my service. Let's see if it'll copy this. Oh, no. Oh no. Repaste it here. Oh, no, your dash just ran. Yes. Okay. So what happened was dash running worked a little bit too good for me. So I stopped it, I killed the container, then removed it immediately. That's why you can't find it. So Docker PS is a way of listing your containers that are running. You can also say Docker container list. Should also give the same thing. And then if you want to see your images, you can say Docker images. Images. You will see the images. Let's just run it again. Docker run dash Docker. I think it might be this terminal's playing around with